Thank you for coming out tonight. My name is Trent Fowler, and I've organized this event on behalf of the Vinci Institute. So we all know that work is a foundational part of human life. Some would say it's a defining quality. The kinds of work that we do and the kinds of work that we aspire to do say a lot about the vision that we have for our life. And historically, changes in patterns of work have signaled or driven changes in broader society. And big changes in patterns of work have signified big changes in society. So for historical examples, we can see the rise of the merchant class after the Black Plague in Europe, the rise of the middle class after the Industrial Revolution, both of which have given rise to ramifications that are still playing themselves out. So it's my view that we are on the cusp of changes that are at least that big. Two of these are going to be driven by the blockchain and artificial intelligence. And here to talk to us tonight about the intersection of these technologies and the future of work is Jay Swartz. So without further ado, I'll turn it over to him.
I need to get my projector.
And yeah, actually, I think Tom was going to say a few things about the Institute. Okay. Yeah, I'm sorry.
All right, is this thing working?
Set up earlier. Is your laptop on?
There we go.
There we go.
All right. So for those of you who don't know me, my name is Thomas Fry. The Da Vinci Institute runs the third floor of the Compass Bank building here. We operate it as a co-working facility. So anybody that needs an office, we have some wonderful office space here. There are around 35 companies, something like that, up here. Most of them startups. And it's quite an eclectic group of companies. We started off thinking we wanted to work just with tech companies, and then kind of came to the rude awakening that every company today is a tech company on some level. And then, so we have companies that are. We have a drone company that's doing drone agriculture, flying over fields and mapping out the fields. We have a game design studio. We have an Internet of Things expert. We have a cannabis company. We have a gentleman who does tutoring for chemistry students that it helps them get past college chemistry. And what are some of the other ones, Roger?
Patent attorney.
The tunnel engineers.
Yeah, the tunneling engineers too. Yeah, that just work on tunneling projects all over the world. So any of you that might be interested or know somebody that might be interested, feel free to stop us afterwards and we'll be glad to give you a quick tour. Roger's our facility manager here. He's here all the time, and so feel free to talk to him. But and then I work as a professional speaker. I travel around the world giving talks. I'll be leaving on Saturday for South Korea. I have a couple talks over there, and I'll be going back in July to South Korea, and then I'll be going to Moscow and Australia and a couple other countries after that. So it's my role is to help expand people's thinking about what the future holds. Now, one of the topics I talk about a lot is the jobs topic, about future jobs. And what Jay's going to talk about tonight is that topic. Data analytics is going to be one of the hot jobs of the next decade. If you're thinking about getting into it, that's one where the sky's the limit. There's a few other ones too, but I think we're in for a real treat tonight. So feel free to stop us afterwards. We'll fill you in a little bit more. Thanks.
Thank you. All right, good evening, everybody. Thanks for coming by. So, as Tom and Trent said, I'm here to talk about AI, the blockchain, and how they come together to shape what is going to be the future of work. So, I'll talk a little bit about me, a little bit about the company I'm working for, and then touch on AI as a discrete topic, then blockchain, and then this future of work idea, where it's headed to, and then some of the accelerators that are making what the future looks like and when we will see that future appear more quickly than some people may realize it's about to happen. And then I'd like to leave a fair amount of time at the end for discussion, for questions, and that type of thing. So my background is I started in tech back in the late 70s, back in the days when you did things called cold starts of computers. They turned them off at night because they didn't want them to run all night. Everybody went home anyway, so there was no internet, none of that. And so my first startup was Osborne Computer, and they made a computer that was a little bit smaller than the size of that table there. It was declared portable and had a little 4-inch screen on it. And I worked my way up the curve in what was IT back then, and ended up leading Seagate Technologies IT operations around the world, living in Singapore for a while, doing that, and then decided to take a run at retiring when I was very young. I realized I couldn't do that for very long. I'm not very good at being retired, even today. So I got into a few startups, and actually was a bunch of people in a room and saying, who can do marketing? And put my hand up, and 15 years later I realized I think I did the wrong thing. I was actually fairly successful as a marketing guy, and ended up going through a couple of startups, and then to Sun Microsystems, which is now Oracle. And as Sun was being purchased by Oracle, I realized I really should get back into tech, so I started getting my chops back, did websites, a variety of things, and then migrated into machine learning and AI in the very early days. Spent a little time at a computational cognitive neuroscience lab, modeling cognitive biases, using what is today called deep neural nets, but at the time they were just neural nets that were spread all over the place, and it's pretty much the same thing. Then went to Welltalk and spent the better part of 4 years building an intelligent agent based on IBM Watson. So I'm a Watson expert. I know how to make Watson dance and sing. And so if you need to know about Watson, you can talk to me about that. And I've been a startup advisor to a number of startups in the area. I actually have about 5 right now that I'm advising on how to do their AI planning and strategy, and what to do about that. And then about 7 months ago, got affiliated with the company I'm currently with, which is Black Box AI. And Black Box AI brought blockchain into the equation. And so I've, in the last several months here, learned blockchain as well. So what Black Box realizes is that it's challenging to set up these new technologies. These are just some of the data points. One of the things that most people don't realize, and particularly the people that are funding projects, don't understand, is that AI and blockchain is kind of like standard development work where you spec it, build it, and deploy it. But AI is a different animal entirely. It actually is what I call a seed and grow system. So it's, as opposed to the normal engineering cycle, which is what I call one and done. You do updates and versions and things like that, but essentially your product is done when you built the thing at the beginning. Machine learning models need to be grown over time to get them to perform at the levels that you're attempting to have them perform at. And they also suffer from a dependency on stable data. And what most people don't realize is data streams move around subtly. They drift. So in the manufacturing environment, different pieces of equipment wear out and slow down and start performing differently. So you have to train an AI system that's watching a manufacturing process on a regular basis to accommodate those variations that happen. If you're dealing with human-generated data of any type, that varies widely with laws covering their behaviors, language things. When I was at Welltalk, the linguistic movement was pretty alarming, actually. New words would appear that I hadn't trained Watson on. So I have examples of I never trained it on twerking, but lo and behold, somebody asked a question about twerking and confused my system. And so I had to go in and yes, this is legitimate. Somebody hurt their hip twerking. And so, go figure. But human language is that way. It moves all the time. And actually, one of the reasons you see that Siri is so problematic in those kinds of large-scale systems, they're trying to solve for the entirety of language. That is a nearly impossible task. I managed to ratchet out 97% accuracy from Watson, which is unheard of, but that's because I bounded the problem space very, very tightly. And actually, one of the technical tricks we use is I didn't use a Watson. I actually had a group of Watsons, each one trained for specific subject matter. So I had a maternity Watson, I had a dental Watson, I had all these Watsons, and when I bound it in that space, they perform very well. So that's one of the many insights into AI is bounding your problem space. If you do that, you can make machine learning things do amazing stuff. If you're trying to solve the entirety of the English language, you're going to have a long road ahead. So there are a great many problems. That's just one example of some of the challenges that are in the way of this, and that's part of what's retarding the adoption of AI. Oops, wrong direction. And so this group is actually working on the blockchain, and the general model that most blockchain companies are using is they have a foundation entity that manages the tokens and the underpinning technology, and then they have a commercial wing that does the commercial work, buys and sells and implements and things like that. So that's the way we're set up. I'm on the implementation side in the BAI. And so we use a standard process. It's just basically go into the client, figure out what the problems are, identify the ones that you can solve with AI or blockchain, and focus on those, and just develop them through a normal process. But we do have this little infinity sign here that says you just keep reiterating over this once you've built it. It's never done, and that is actually one of the major sticking points, is for people to get their head around that idea that they need to have a ongoing support environment. And it actually is a good business practice, because then you're tuning your environment to the movement of your markets and your client base. So there actually is sound business logic behind why you want to do this. Not to mention that technologically, if you leave it alone, its accuracy tails off over time. We also have an ecosystem model that, if you really are interested, you can go to Blackbox AI or ping me. So part of what we're looking at is building a collective of individuals so we can do a low friction community of people, so that we don't have to pay the market rates for reaching across and using old methods or current methods of contract work and hiring people and doing all that. This is a more efficient thing where people in the economy and the ecosystem actually can exchange tokens without having to have the contractual overhead and a variety of things. But enough about us. So this is about AI, okay? Now, one of the key things you should take away from this is there is no I in AI. Okay? No intelligence. We're not there yet. In spite of all the press and all the hoopla, this is still just basic machine learning that has been taught. It doesn't learn, people teach it. And so anytime somebody comes up to me and says anything about learning, real-time learning in AI, I know they have no idea what they're talking about, because these systems don't do that. There is a good example of one that was done, which is called Tay AI. If you've ever heard about that, it's a Microsoft product that was built for the Chinese market and was intended to be an intelligent friend. And it did very well, in the Chinese market, where they're much more conservative and disciplined, and not quite so outspoken. They brought it over to the United States, and within hours, it became a bigoted, racist monster. And they literally had to pull the plug on it, and it actually accidentally got turned on again for an hour or two, and then they killed it permanently. It has not come back.
You did turn yourself back on.
But again, if you narrow the scope of what it is to something realistic, so examples up here are seeing in an image an item and being able to correctly identify it. Things like that are well within scope. Doing translation. Now, this is not interpretation, just raw translation. So the right string of words to put together. You can do complex translation work with machine learning today. It's actually gotten to be to the point where you can teach high school kids how to do machine translation systems. It's that straightforward. And there's all manner and kind of image recognition, IDs, things that can be done. And actually one of the more leading edge implementations is in China today. They've begun to do what used to be just a TV show, tracking everybody in the city. They have cameras everywhere, on every street and every intersection, and they spot people breaking the law, and they've begun the march into social engineering. And their plan is to instrument all of China with this system so that they can maintain their standards. So this technology is ready if you have the wherewithal to invest in it and bound your space. That actually would be, I'm sure it's an incredibly complex system. It's not a single thing. It's a large infrastructure of many different moving parts. And so I like to put this image up because it kind of gives you intuition on what machine learning is capable of doing. Now, this happens to be an influencer model on social media, but there's no reason you couldn't build a similar structure to determine how your manufacturing operation is going or something. And so on this, one of the things is if you see these bubbles up here, those are the high activity nodes. And you'll see that down in this color, they have very few large bubbles. So in some business settings, you don't want choke points. Okay? These are the equivalent of choke points. In a social setting, they're influencers. So those large bubbles, that one person has a significant amount of influence over everybody that they touch. So in some settings, you may want this kind of a pattern where you don't have any bubbles, you have a nice, even distribution of data flows. That's your optimum. In other settings, you may want to do these kinds of things, but you can see that this is something of an island out here. And again, depending on your business problem that you're trying to solve for, that may be a good thing or that may not be a good thing. So these visualizations are one way that data scientists interpret the data, and then what you do is use this and these bubble patterns to then train another layer of machine learning that says, when I see maybe this happening, I take actions against that to lessen the influence of that one individual in this flow, if that's what I'm trying to accomplish. Or vice versa, if I see this and I don't want that kind of dispersed flow, I do want it to go through a few key influencers, I can build machine learning that'll drive that section to begin to look like this section. So there's a huge variety of things that can be done. But at the end of the day, it's not intelligent, as I said at the beginning. It's actually just very simple separations. Okay, at its core, most of machine learning is determining, oops. This used to be in 2014. That was a very difficult machine learning problem, cats and dogs. People would work very hard to try and figure out how to just train a machine learning system to say, is it a cat or is it a dog? But that was solved in the late 2014 timeframe, and now that too has become an off-the-shelf. I can go grab an algorithm that's already set up, feed it a bunch of pictures, and cat and dog problems are simple as all get out today. It's important you think that through. That's 4 years, okay? Up until that point, people were working for 20 years trying to get something like that to even come close to being possible. And then suddenly in 4 years, they've gone from cat and dog to, I can tell you what species, I can tell you many different things, and train one large model that can figure out a dozen different problems. Whereas this is where it all started. Now, interestingly enough, in a lot of cases, machine learning or business problems can be solved with simple linear models like this, right? If I can arrange my data and draw a line through it and tell which side an item is on, a good example of this is fraud detection. All you're trying to do in fraud detection is figure out, is it a fraud or is it not? That's all you need to know, and that actually also has become a pretty straightforward process in today's world. Now, there are a great many models. These are all different types. And this is just a sample of the different types. There are literally hundreds and hundreds of different models that you can use. And then there's families of models. So there are many, many choices. And in today's world, that's why you still need a data scientist to wade through all this, because we know when one of these models is better or more efficient than one of the other ones. There's no way to know all of this all the time, and actually a vast majority of your time as a data scientist is spent doing experiments. So on my Watson thing, we did hundreds, literally hundreds of experiments manipulating the English language by certain pluralization patterns and a variety of different things to get it to understand the language and understand basically how to answer questions that came in, because we didn't know what the questions were. And so the other aspect of machine learning that you're trying for is generalization. In a one and done model, you have to have all the rules defined, thought through, all your edge cases have to be considered when you make that solution. Something out of the ordinary comes in and that system breaks. So you have to go in and do maintenance on it. Machine learning, on the other hand, is intended to get the core thread of behavior through a model and then generalize to those edge cases, so you don't have to train it for everything. Now, some edge cases are far enough out of the distribution that you have to go in and do those retrainings. But again, and I don't think anybody here wants me to take you through all the mathematics involved, because it would take me all night. But basically, there are techniques you can use, mathematical techniques, to separate your data and align the data. We used to do maximum Euclidean difference to get this thing to behave itself. So if you've got 3 questions, you actually figure out which ones are mathematically the furthest apart is the technique you want to do to get your optimum performance. So that's probably Greek. I'll stop talking about that. What you're looking for is these kinds of attributes in your data. If you have whatever business problem you're trying to solve has this type of distribution of information, or one or more of these types, it is a good candidate for a machine learning problem. So as you can see, limited judgment, high volume, more data is always better with machine learning solutions. And that's another misnomer. If you're going to do these highly advanced things that you see in the press, called deep networks, deep neural networks, and there's DNNs, which have CNNs and RNNs, recurrent neural networks, and all of those things take millions of records to train. Those other models that I showed there earlier only take thousands. And so thousands of records is something that's in reach of most businesses. Millions is only for the Googles of the world and the very large businesses. Although, when I talk a little bit about where we're going, there are actually machine learning techniques today that you can use to generate training data. So you no longer have to have real data. The old guidance was that you had to have completely unbiased information, and you had to have it from a real source as opposed to made up. So you couldn't do Mechanical Turk, or you couldn't use Mechanical Turk people to generate training data and things like that. Turns out that's not true. And that's how I got my 97% with Watson, is I disregarded IBM's guidance and said, I think we can find a way around it. And that comes back to those mathematical differences. If you actually apply those techniques to made-up data, you can make made-up data perform almost exactly as good as real data. So there are techniques that are out there to do that. But these are the kinds of things you're looking for. And this is actually part of what's leading to this general concern about the future of work, which is putting people out of work. So if people have a job that looks like one of these, where most of their day is spent in one of these spaces, like doing the same thing over and over again, or if there's a room full of 100 people doing the same thing, anything that has these kinds of hallmarks is ripe for being fully automated. So you're going to see any kind of setting where you have all this, one or more of these features, somebody is going to come along and build a system that'll do that, and all those people will eventually not have anything to do in that job role. Now, there's also a reality that every new technology that's ever been made has generally created more jobs than it's taken away. Now, we might be on the cusp of that breaking down, but that I don't know that yet.
I just wanted, could you elaborate on low-cost mistakes, what you mean by that, and also why is it a driver? I would think if the stakes were higher, you'd be more motivated to.
Actually, this is because you don't have to have that precision in your system. So if a mistake is not a critical thing, so if you're doing something where somebody's life depends on it, okay, I would not use machine learning. It's not a good idea, because these are probability-based systems. So in those settings, you want to have a human looking over its shoulder.
Like self-driving cars, for instance?
Well, actually, ironically, self-driving cars right now, statistically, are 100% better than humans. So there was one person that was killed accidentally, okay, but that is after self-driving cars have driven twice the number of miles that humans have killed people. So in that same amount of mileage, humans killed 2 people. Self-driving cars killed 1. So it's better, and that's actually an interesting way to look at this technology. Is many people think, oh, I'm going to put in machine learning for perfection. No, that's not what you want to do. Very rarely is this stuff 100%. What you want to do is beat human performance. If you can do better than humans, that's what you're looking for. So in the case of self-driving cars, they're 100% better than people are so far. And so in my book, I'm actually looking forward to self-driving cars. I'll be happy to turn it over. Once they get it ironed out, I don't need to drive it. And I trust that more than I trust all the maniacs drinking their coffee and tweeting and doing whatever the heck they're doing.
What do you mean by limited judgment? I'm assuming that means it doesn't require a lot of depth of judgment.
Andrew Ng uses the example of a decision that can be made in a few seconds. It's kind of, so if it's like, oh yeah, okay, I get that, okay. So if you don't have to think it through a lot and go, well, maybe this, maybe that, that's what limited judgment is. So it's almost verging on a mechanical thinking.
Understood.
And so you don't have to read this. That's not the point. The point here is this is just the manufacturing sector. Okay. These are all the opportunities for machine learning in manufacturing. That's this big piece on the, whoops. This big thing. So all these different things are different, full, large-scale applications in the manufacturing environment. And then they leak out into all these different functions that are cross-functional. And I could put the rest of the industries up here, but every industry has this same level of potential for machine learning. So it's going to be in a lot of places. So I'll let you read my blockchain cartoon. And that's pretty much the level of understanding of blockchain in the executive community at this point in time. It's a buzzword. I have no idea what it really means. But really what it is, it's an immutable ledger of transactions. At the end of the day, that's what it does, is it keeps a record of every transaction that preceded your involvement. So if you are, the example for a lot of things is coins, but we use and focus on blockchain for other purposes, not for the actual coinage and those types of things. Which is that second bullet, smart contracts. You can automate the contracts. If you can figure out a relationship between a supplier and a manufacturing floor workstation, you can automate the flow of product from that supplier into the workstation in manufacturing without having anybody in the middle. Once you've set that up, it can resupply your production line automatically with a smart contract in play. Now, this does move back in that direction of needing to know all the rules, because it is a contract at the end of the day. So it suffers from that type of thing. Although that's one of the reasons we are marrying AI and the blockchain, because the AI can overcome that and do that generalization that I was talking about before, where you can kind of get the rules and it becomes more like a policy than a rule. They're guidelines that you should stay within, and they're not hard and fast black and white type rules. It's also a trustless network. So what that means, it's kind of bad marketing in my book, that sounds a little scary, but actually what it means is you don't need to rely on a central rule system or a central control point like a bank or a supplier or something like that. It can be, as long as you vetted the participants at the beginning, when you set up that smart contract, once it's running, you don't need to worry about it. Anybody that is in that ecosystem is a trusted participant and can be tracked. The important part is they're trusted because you know that every action they take that is involved in the blockchain can be recorded. And that's why actually it's, in my mind, it's kind of surprising that people worry about illegal activity and drug dealers working on the blockchain with Bitcoin. It's kind of like, well, wait a minute, every Bitcoin you have has a history. I can go tell you where every Bitcoin came from. Just give me the Bitcoin information and I can trace it back through every drug dealer that laid a hand on it. So the account holders can be anonymous, but that is sufficient information for the FBI to go find because of the pattern of it, because it tracks where they were and a variety of things. So actually, cryptocurrency is a terrible thing for criminals to use because there's a history. So it also gives decentralized, decision making. So you don't have a central control point, and it's for value exchange. Is generally what blockchain, the implementation I prefer to think about is.
But isn't it true, if you've got so much data, who's gonna bother to go look to find that one little detail? Or is that not true?
People are not going to bother to look unless they have a reason to look, which is why, you know, if somebody's suspected of being criminal, it doesn't have flashing lights on it that says they're doing something bad. It's just that there's a record of it for anyone who wants to go look.
Would you just delete the record? Or delete the
It's
survey
immutable.
record?
The key thing about the blockchain is it never ever goes away. It's always there, which is actually one of the challenges, and going to be with GDPR, the European privacy laws, and the key part of GDPR is not the tracking side, it's the forgetting side. GDPR says you can't keep data in perpetuity. You have to age it out of your system when the people that are involved with it are no longer in your system. So you have to purge it. That's actually the hard part of GDPR, in my mind. So there are actually a multitude of technology plays underway to solve some of these problems. So they have now child chains, so you can break the chain and forget information. We're working on a matrix, so basically a block mesh, if you will, or a block fabric, so that you can distribute the information across multiple chains, so that you can say private information goes on one part of it and public information goes on another. You can do certain techniques to separate out those problems so that the parts that you have to forget can easily be forgotten, and the pieces you can keep. You know, so for example, if you have a record of my health history and I change providers, it's okay if they keep my general information about, you know, my age and history, and can use that data to determine for a large population how to handle whatever condition it was I may have had, to help people. But I don't want them to have my name in there. So I'm okay with them having my data in there because it's not related to me. And so these mesh systems allow you to do that, to segregate out the data to the places that it's going to live for a long time, but not be able to be traced back to an individual, any one individual. So these are some of the insights. The stuff on the right is a little bit interesting in some ways. So kind of in the middle here, this is a history, if you will. So in the beginning, there was no network. Then they went to mainframe, client server, and now peer-to-peer. This is actually technologically one of the harder problems for the engineering types to wrestle with, is there's no central server. It's not client server. You don't have that kind of mechanism. You don't have all the checks and balances that go with the client server system. It's a peer-to-peer model, so you have to build it somewhat differently. So there's different technical requirements. This is more of a political statement. So this is throughout mankind. This is kind of the history. So what the more forward-thinking blockchain people are looking for is this future of work that I'll talk a little more about, where managers and all the overhead in a corporation goes away. You don't need it anymore because you can build blockchain models that keep everybody on track and instrument that with AI componentry that will make the decisions better than any human can. And we're actually at that point in time right now. We've actually crossed over into a place where the technology to solve a lot of the world's ills already exists. It's our societal norms and legal constraints and a variety of other, and the people in control, the incumbents, are all resisting that movement for a variety of reasons. Most of them good intended, but unfortunately yielding bad results. And so, for example, I tell folks, I could go in and clean up the IRS within a year. You give me the money and don't get in my way. You could tear out all the stuff they've got, all the old 370s they've got spinning around, because they still have them. I know it for a fact. They're out there. Some of my old COBOL code is still running at Blue Cross. I know that, sadly. And it's because of that, you could pull that out and put a smaller, cheaper computer system in place, and they could solve all those problems in a heartbeat. But you'd have to get everyone in Congress to agree, and you have all the social mechanics and inertia that have to be gotten around. The technology is here. We've got it, and it can be used. So this is kind of another way to think of it, because the actual technical components that make the blockchain work are called dApps, which is what this thing on the bottom. So it's used to be you discover things on the back of a magazine, and then Amazon came out, you know, and then it was so one matchmaker, one merchant, and these guys, and many to many, and now none to none. It's kind of the way to think of it. There is no central collection. It's a bunch of little dApps. They're connected to other dApps, and they sort out all the complexities that the eBays, the Amazons, and so on used to do and make their money by sorting out those complexities. If you do your dApps correctly and instrument them into the correct ecosystem, you don't need an eBay or an Amazon to exist anymore. They serve no purpose for you. If you can completely redo everything, which again, you're not going to be able to completely redo everything anytime soon. So, so this is the other side. So this is the compare and contrast to the current legal environment and its implications, and then what smart contracts do for you. So again, they lower the friction, they make things happen more easily and more fluidly. But they fly in the face of all the established institutional models and laws that we have in our country. And we're actually, our group is in the process of working out how to do an ICO, and there is zero legal precedence. So our legal advisors, I can get this many attorneys in and I'll get this many opinions. And everyone changes their mind 5 times a week. It's crazy. And so that's a hindrance. So the people that have gone ahead with their ICOs are just basically throwing the dice and hoping that the SEC doesn't show up on their doorstep. And the SEC has weighed in several times. Sometimes they're, oh yeah, I'm not worried about it. Sometimes, oh yeah, we're going to hammer you if you do it. And right now they're on that side. If you do tokens to pay for services, that's a security. If you're using it to build anything, right now the SEC believes that's a security. They're going to treat it like a security. You've got to obey the security laws. So all that overhead of the current legal system drops right on top of you, and you've got to play that way with all the machinations that go with it. And so that is actually what's driving a lot of blockchain businesses overseas. We're in the process of setting up an operation in Singapore for the foundation so that we don't have to deal with the laws. Okay? And so we transfer in and out, and I'm talking to several clients that are building similar, they want us to help them build similar systems for their business situation where they operate irrespective of the borders, literally a switching system, so that if for some reason the law, the climate changes towards this, that, or the next thing from a legal compliance perspective, we can move the business out of one area and into an area where it's okay to do whatever it is they're doing. So again, this is not evasion, this is avoidance. Okay? And that's fundamentally what people are working on right now, is how to play inside the laws but minimize your overheads. And so that's pretty much where we are with the blockchain today.
Can I ask a quick question?
Sure.
So, I'm envisioning something like, say I had wanted to have a retail shoe distribution thing. So I would have agreements with some wholesalers through the blockchain, and they're going to ship, 100 shoes, or this one, a couple hundred, or whatever. and we have the contract set up, and then customers could come to my website or whatever, and I send them out just like I would have. I'm envisioning an internet business. Send these shoes out, for making a profit. And so how would the profits in that get recorded, that some of these entities that you were sort of talking about would understand that, how much money that my business makes? Is that a good model for blockchain?
That could be, yeah, that could be a good model if all the right pieces are in place. You'd have to be able to comprehend the relationship of the businesses, so that and the ideal flow model would be you set up a contract with the supplier that says when you get a signal and an address, you send shoes to that address. And so you don't take the inventory, you put up the web page, that you build part of the smart contract that goes to that supplier, that sends the signal to the supplier. And in that contract, you can have multiple players. You're one too, you get paid. Okay? And you can set that pay up. Typically, if you're full blockchain, you'd set it up in a token model, you get paid tokens. But there's no reason you can't set that up to flow into a regular US currency, exchange as well. You could build that into a smart contract. But then you wouldn't have to go back and re-engineer any of that. Just however many shoes get ordered, that's however many shoes get shipped. And they get shipped to the addresses, and you instrument your website with a piece of the contract that is assigned to, say, me. If I go in there to buy a pair of shoes, I put in my information, so suddenly I'm on the blockchain for your business. And so that's another one of the subtleties, is you can look into the blockchain for your business and see all your clients. They're all there. You don't have to go out and find them. So you could put a D app over that blockchain and say, summarize my clients, and do all that accounting work and all those other things that you normally have to pipe it from this system to that system to this system. If you build it all in a blockchain model, then the blockchain is handling the flow of information, and your D apps are like windows into that flow. And so if you want one to be your inventory control, to see how many returns you're getting, and look at that aspect of the data flow, or if you want to see how many you've sold in this region or that. Although you can begin to see how you suddenly don't care so much about that unless you're doing local advertising. So if you do placement advertising, you want to see who buys them where. So you may have a reason to say, I'm going to do more placement advertising in Denver because more of my shoes sell there. Or I want to build my business in Phoenix, so I'm going to start advertising in Phoenix because hardly anybody buys your shoes in Phoenix. Things like that. So, yeah, that's a good solution.
So it's almost like taking Amazon and distributing it.
Yes.
Okay.
Yeah, and making it interchangeable and interlock, like puzzle pieces. So you have one piece of what is available on Amazon, shoes, and somebody alongside you has the sock business, and somebody else has the pants business, and so on. And they're all individual players, and the blockchain becomes Amazon. Just facilitates that flow. So, yeah.
Okay, thanks. That helps a lot.
And so I don't think I'm going to spend too much time on this. This is how it does it. The only reason I put this slide up is everybody worries about how do you get into these things, and if it's public and on this blockchain, why is everybody and their uncle hacking the crap out of this? Well, this is why. Because they all operate on these cryptographic hashes, okay? And a hash is a computer-like thing where it just adds the bits and bytes in a document and tallies them. And if you change anything in that document, add a space, make a capital B instead of a small b, add a comma, the hash changes. So a hash is a guaranteed way to ensure nothing is changed in that block of information. So the actual information itself is not there, it's represented as this hash. And then this hash comprises this and this data set, which are added together to get that number. So it's a mathematical modeling system that just guarantees that nothing has moved since the last recorded activity. And this recorded activity is usually not stored in the blockchain for two reasons. One is if you store it in the blockchain, then it does become visible. But the more important reason is the blockchain, you can see block 16, 17, you can imagine millions of people using this, you'd have block 20 million. And each one of these gets a little bit bigger each time as you go through an iteration. So so this balloons dramatically, unless you have some other way of offloading the volume of data. Right now, I forget what the number is, but it's the current ledger for Bitcoin is, I think, a gigabyte of information. And so just to process, do the math on that to verify that you've got the right transaction has become difficult. And so that's one of the challenges with blockchain is this thing. Currently, no one has solved this ballooning problem very effectively, and that's why so many people are working on all these techniques of children chains and meshes and things like that, so you can pack this back down again and it doesn't turn into a monster in a matter of months or years. So it does take time, but again, for anybody to adopt this on a long-term basis, you're going to want to be able to have an answer for how do I keep this at a manageable size and shape.
So are you saying that every transaction in Bitcoin has a gigabyte of data along?
Everyone. That blockchain, and then it gets worse. Everybody that's in the community, they all have that same gig. It's spread all over the place. And so there's a massive amount. I think Iceland is being crushed under the computational weight of blockchain. They're burning through so much energy that it's actually not cost effective anymore. It's more expensive to do the calculations than the value of the Bitcoin. So the technology has some challenges, but the example I try and use for everybody is the idea of back at the beginning of the internet, Linux or Unix at that time, was proven to be a vastly superior technology. It's way better for handling large-scale distributed data systems and networks. But when it first came out, it was full of holes. A kid could almost break into a Unix server because it had so many uncovered backdoors in it. But over time, all those backdoors have been closed, and now the internet generally runs on Linux, which is a derivative of Unix. Blockchain's in that early stage. Right now, it's incredibly promising, but it's got some pretty ugly features that have to get solved before it's going to get widely adopted. Now, the good news is technology is moving way more quickly than it was 30 years ago, back in the early Unix days. And there's a lot more smart people trying to figure this out. There are armies of people trying to figure out how do I make this faster, better, how do I get around all this crap and still have the attributes of it, the unbreakable security and the longitudinal record back through history so I can go back and find out exactly where this thing came from. Those are the powerful parts of blockchain that everybody wants, but it comes with this baggage of huge overhead in today's version of the tech. That day that problem is going to go away, probably in a year or less, I can think. And there are already people working on some really cool ways around it.
Is there a simple soundbite way of understanding the association between the data and the hash? how do you use the hash to be able to access the data and keep it straight?
The hash is a unique, and you can tell by how long it is, that actually, I forget what the actual full number is, but there's quadrillion things that, that long a hash can
But you're saying
represent.
the data is separate from the hash.
It's just a reference, it's a pointer.
Right.
So that points to wherever it is. So this is the area where you have, this is on a classic server somewhere, a record with all the gory details in it. But the blockchain can tell you where that is using the hashes.
Is there a simple way of understanding how the hash of the blockchain will validate that data, that it hasn't been hacked?
It's these hashes. So basically, this gets passed along. So when you get this, there's the previous hash. Okay, so over here, a similar, it's called a Merkle tree. Similar tree was built. Okay, and so it has a top level hash. So it compares these two. If when it tries to do that, before it does a transaction, it verifies that nothing is moved. And actually, that verification process is distributed across all the participants of the blockchain. So the security is, I might be able to tweak mine and mess around with it, but it has to be verified with everybody in the room. So if I tweak something, my hash isn't going to line up with everybody else's hash. And that's really the power of it, is that distributed decision making, to where you can tell instantly if somebody's doing something they shouldn't be doing.
So are you hashing on all this data that is not in the blockchain? Is that the
Yes.
you're saying there's a pointer? So that way
Well,
if
different
somebody-
models, again, if you want to get really technical about it, then it maybe. But intuitively, yes. It's
Okay.
the data, it's an email. And so if you just tally up the bytes in the email, you
Yeah.
come up with a number.
Right.
And that's unique for that email. If you change any little thing on there, your hash is going to change.
Right, right. So the data stored outside of it is still known as protected, right? Because if you're going to try to rehash and compare, you're still comparing from that original data set. I got it.
Yeah, yeah. Well, and what some people are trying to do is spoof it to say, oh, this data is really what, I'm changing data 1 to data 20,
Mhm.
okay? And you try and spoof around that and force data 20 to have some other kind of a hash. And basically, even if any one of these components gets changed, this hash changes.
Right.
So you can't manipulate
Okay.
anything very effectively. And so there's a lot of ways this blockchain can be used. It comes with those exposures that I was talking about. There's a lot of things that have to happen before you can actually realistically realize these benefits. But there's a lot of people working on it. These will get solved. You will be able to see these things in the not too distant future. So this is not a 20 years away. Some of them are actually, again, because of the incumbents and the inertia that's in the way of actually implementing these things. One thing a lot of people don't realize in the healthcare system that I worked in for quite a while, price information for providers is considered a trade secret. Their lobbyists manage to get laws written on the books that say it's a trade secret. And when it's a trade secret, it can't be shared. So you cannot do what's the average price for an appendectomy. That's a trade secret. You'd be actually using a bunch of people's trade secrets and adding up a number, and every one of those people has a right to sue you. So it's going to be a long time before you can turn that one corner. And our laws are littered with these things. That's what lobbyists are. That's what K Street in Washington is all about. A crafty attorney who can say, if we say this way, we're going to make $10 billion, and no one's going to be able to get into our stuff and compete with us because we've got to protect it because of the law. And so that's the kind of inertial elements that are in the way of us doing some of the things that are here.
So it's almost like built into this thing is cloud computing.
Yeah, that's a technicality. Cloud just means where. So the cloud just means you don't have a room in your house, or you're not connected to a given room somewhere. You're connected to a network, and the backside of that network can have a server in Timbuktu and a server in Detroit, and you don't care about that. And that's really all the cloud is. It's just you've got an endpoint that you look at, and what's behind that endpoint can be what a bunch of other businesses are working on. And so that's another thing. If you drive through any business park, you see all these business names, you don't know what the heck all these people do. And they're doing bits and pieces of these kinds of large systems behind the scenes.
Mm-hmm.
They make a whole business out of doing one small thing in that flow.
Right.
Okay, so we've kind of been talking about today, where we are, the near-term horizon. I'll answer one more question before we start edging out into the future.
So I was aware that cryptocurrencies were kind of an environmental disaster because of the enormous energy consumption. I was hoping that that was a feature that was particular to cryptocurrencies and not blockchain in general, but it sounds like this ballooning problem is a feature of blockchain. And
It's inherent in the blockchain model. It's a different problem space with the currency because currencies are transacted like money and they're bought and sold, and so that generates a lot more transactional behavior. In a smart contract setting, the volume flow is much lower, but still high enough that you'll hit a wall soon enough. No large corporation really wants to go all in on the blockchain. IBM has got their solution, and others are starting to put it into play, but I guarantee you they're going to be hitting a wall. You know, if they had a sudden surge of adoptions, I think they'd find themselves in a lot of trouble quick. And what would happen is, all that would happen is the response time would go down. Suddenly a 200 millisecond transaction that you can't notice the delay on turns into 700 milliseconds, which you can see. You can't quite see it, but you know when you're past 500, and then pretty quickly it's up into seconds, whole seconds. You're gonna stare at your screen while the thing resolves itself. So yeah, they would quickly find themselves in a response problem. So the contracts couldn't execute in a timely fashion. Now that could be extended because if you have no people in the mix, and it is truly a smart contract, that I don't care if it's an extra few seconds here or there. So the tolerance level can change. The reason for a 500 millisecond response time generally is because you have a human on the other side looking at it, and they don't like more than 500 millisecond delays. That's all. And it actually has been proven, another little technical tidbit, a 500 millisecond delay impacts your creativity by 68% negatively. That little bit of hesitation slows down the creative juices. So there's reasons for it, there's good reasons why response time matters. So you don't want high latency in anything that has to do with a person. But that's the promise of the blockchain. You're eliminating the people from it. If it's all automated, okay, maybe 2 seconds is okay. But again, if you get up to millions of transactions, guess what? Your system can't keep up with the flow. So in a very large scale setting, you've got that problem. That's actually one of the reasons I'm confident that blockchain will get solved is, I used to be an assembler programmer. And that's where you slice bits and you're doing bit twiddling and you're trying to squeeze out every little, mask process. To be honest, it's been so long I don't think they probably do that anymore. But there used to be ways to accelerate it, where you'd go in there and just twiddle bits and get it to behave itself. When you're doing banking back in those days, it mattered and you needed to do it. No one's applied anything like that to blockchain yet. So I know there's a lot of room for efficiency gains if somebody just sits down and puts their mind to it. And then there's all these other mechanisms and alternatives. So I'm very confident it'll get solved pretty quickly. There's too many people with too much money in the game trying to make this happen. It should resolve itself, as I said, in about a year. I say, give or take, it'll start to get realistic. Okay, so all those things I was talking about earlier are pretty much now, real time, things we could do but can't get to for a variety of other reasons. As those problems get resolved and as the world is forced to move in new directions, the general idea that we're professing, but not, I personally am one of the naysayers in my business, because I'm a little bit more of a realist. I'm used to having to implement it and live with the clients and having them talk to me about how it's performing and behaving itself, so I know we can't do some of these things just yet. But my CEO is out stumping this idea of complete elimination of management. The future of work is totally decentralized. You don't need to have all those pieces and parts, and technically that's quite true. But you still have people, and we have certain things that we want to see and have gotten accustomed to. So it'll be generational before that type of situation can change, or the other motivational thing could be a catastrophic event of some sort that says, oh my God, we have to do this for some reason that forces us into that space. We've been known to do that, like go to the moon, things like that. If you just direct everybody in a certain way and motivate them, we actually could do something like this pretty quickly. So again, this is not way out of land, not in the future. It's largely because of social norms and inertia that it'll be a while before we see this. But when we do, I guess the key thing is a CEO is driven to reduce costs and reduce risk. That's what C-level people do. That's all they do all day long. Find ways to cut costs and improve efficiency and make whatever businesses they have or are working on more profitable. So they are highly motivated. One of the things that we actually experience, I see actually a lot, is having to talk to somebody below that level and explain to them how I'm going to diminish their empire. So I can talk to a call center person about chatbots. I can say, I can wipe 50% of your people out like that. We build a chatbot for a fraction of the cost and you'll be fat, dumb, and happy. And they look at me like, you want me to put myself out of a job, is what I'm really saying to them. And so these truly powerful solutions can only be decided upon at a senior level. And then that moves down into the organizations, and they're the ones that, the Walmarts of the world that say, they just make an edict. No one's going to be an employee, everybody's going to be a 1099, I don't have to pay all that extra overhead. Off they go, that's what they do. And there's big companies that do that for that reason. It's profitable. The people down in the machine are not happy campers about this kind of stuff, because particularly the middle management layer, they all just go away. Nobody there, and no one has a manager to talk to. They're not there long enough to have the normal social dynamics. So they're extracting that from a lot of these large organizations. So there's some challenges in this, and I don't profess to know the answers. There are some times where I wake up in the morning going, I don't know if I'm really doing the right thing, because I'm one of the guys making this possible. So like when I mentioned earlier about the revamping of the IRS, well, I could do that with probably 10% of the people as well. I take 10% of the people and a fraction of the budget, and nobody got in the way and they didn't screw with me, I'd be able to revamp the IRS with hardly anybody, because it'd all be automated. You wouldn't have to worry about it. You'd get your good taxes right, and you wouldn't be able to cheat on them anymore. But the net result would be people wouldn't have to spend time on taxes. So anyway, future work is this general idea of decentralized management. Management probably shouldn't be capitalized. It's decentralized control. Management in the classic sense is going to change. You still need people with vision and wisdom to guide people's actions, because you can't possibly make a contract that's so smart that it knows everything. Even with all the AI in the world, it'll be a while before you can completely dispense with people. But you can vastly reduce the resources required to run that business. If you build a resource ecosystem, back to our shoe guys, you have distributors and providers and designers, and all those people are in the same ecosystem. They can get things done more quickly than the old model of having to write contracts with each of those people, maintain those contracts, and have a whole legal team that has to refresh them, and all that stuff just goes away. Could go away.
So as long as it's fairly rule-based, right?
As long as it follows those other things that I showed earlier,
Yeah.
the patterns. If it's that kind, so complicated, you know, intuitional things that require some understanding of semantics and stuff, be a while before we can get to those. I would say that eventually we can solve those too, but you're in the decade range with that type of stuff before you can get there. For those other kinds of things I showed there, if it's one of those, guess what? That can be done right now if you put your mind to it. So those can be dealt with as quickly as a management team could politically pull it off at their company. So, the key is this friction elimination. You don't have the overhead pieces. You don't have to write contracts and maintain them and do all that stuff. I've already talked about the repetitive thing and the AI assisted decisions. So the key here is not just turning it over to the AI. It's much more having that smaller cadre of individuals having a Jarvis-like thing whisper in their ear. You really ought to move these people over here. You really ought to do this. But the human is still going to be the one saying, yeah, okay, that makes sense. And they have the override capability because these AIs, again, you're not 100%. They will say dumb things. If anybody's ever dealt with Alexa knows that it's not terribly insightful. So our particular model is this general idea of building these modules. Those are all D-apps, the four things down in the corner. So those are implementations of an application that manages and tracks. The proposal cycle moves around. So it goes from the client to the proposal. This is where your management people move to. They're no longer managing all these things. They are just expert advisors. They see, did this proposal get wired together correctly? Does it make sense? Is it, cost effective? Things like that. So your management kind of moves into this role in the flow. So they just weigh in with their wisdom and say yeah or no. The key is consensus. So it's not a manager, it's a couple or three or some number so that you get an average. So it's no one individual who can make a mistake. The upside is you're less likely to have something go wrong. The downside is you're not going to have any, executives that have total control over anything. They've always got 2 or 3 people alongside them, and you all have to line up and agree to get this thing to move forward. And then, of course, it approves. There's a lot of complexity that's hidden in this, but basically there's matching the team. So if you've got a contract to build a speaking stand, you need a carpet person, you need somebody who can build stuff, so all the people necessary to build a speaking platform would have to be worked out. And in a bigger ecosystem, you'd have multiple people, they bid on it, you have all those kinds of mechanisms. You have a reputation system embedded, so it's kind of like Angie's List built in. So anybody that's going to touch this would have a reputation, and you could override that reputation, but generally you'd want to go with that because the reputation is built up over time from successful completion of earlier agreements. So that builds up over time. And then You deliver it, and then it automatically pays all the parties that had a hand in creating it. So when the product is done and shipped to wherever, the signal in the smart contract goes back to everybody in the chain, says you get a nickel, and so on down the line. Whatever it was that you agreed to in your contract. All just flows. So again, this is complicated, but the whole idea is this idea of flowing through here, and we characterize this as the boss token. So that's our token, and it's just the mechanism that you use to divvy up, what you're paying everyone. That's really all it is. But you go down this flow, you've got value points, and that gets pretty complicated about how you determine what something might be worth, and the voting and all that. But the main thing is it goes through in an automatic. So this is just a linear version of that circle I just had. And then you put AI to optimize critical factors where AI applies. So again, you have the broader vision of a machine learning model that can take all the data and spot patterns that you may not be able to spot. And actually that's what AI does particularly well. It spots patterns that humans don't see. So, modifying everything I said are these things. Okay? On top of the flow of AI and the maturation of blockchain, there are these other convergence accelerators that exist and that are part of what is driving the exponential curve that we're on. So, corpora, so basically bodies of information, are the reason that cats and dogs got solved. There are now large libraries of labeled images with cats and dogs in them, so I can train a machine learning algorithm. Those algorithms have been around for a long time. They just didn't have the data. A lot of situations are like that. So as more and more people are using more and more machine learning and building up more and more corpora, it gets easier and faster to train everything. So that's an accelerator, big accelerator. Then the models improve themselves. These are just some of the things. They've got new models that allow you to focus attention, which kind of gives you the contextual flow. There's capsule nets, which kinds of eliminates a lot of the overhead in the current models, makes them more efficient, carries the context forward through time. And there's specific context models, there's actual emergence. That's the one that I am most excited about, is that they have already created some machine learning models that have emergent properties. It may not sound like much, but we are the way we are because we have emergent properties. We do not have a wire in our head that says, I recognize your face or anything. That is an emergent property from our the combination of our visual system, our learning system, our memory, and all of our systems together that work in harmony create these emergent properties of our imagination and our emotions. There are machine learning models that have begun to have emergent properties. That's the beginning of replicating what we are. So that's a big one.
So does that mean a property that's above all these lower level ones that you mentioned, like the vision and the hearing? And
Yes.
Okay.
Yeah. Our intelligence is not a thing that anybody has been able to point to yet. We kind of understand how all of our sense systems work. We kind of understand what we can hold in our heads, but we do not know how we make decisions. We don't really know.
Just ask my wife.
We have a lot of theories. Well,
She's right.
yeah,
She's right.
there you
She's
go.
right, yeah.
And that's where my time modeling cognitive biases is incredibly enlightening to me. We have things, and part of the political problems we have today are because of a variety of biases where we actually will double down on our belief system in spite of seeing hard data to the contrary. If we believe something's red and you can prove it's blue, if we believe it's red, we're going to just insist it's red. We're going to ignore the truth and say, no, I don't care what you say. Yeah, you can tell me all till the cows come home, it's blue. I know it's red, and I'm going to stick with that. And that's what's happening in our political system today. And that's what happens with everybody. All of us are that way to one degree or another. If you learn something one way, you don't want to change it. It's that old dog, new tricks kind of problem. Because once you've learned a way, it's pretty hard to get your brain to think about it in a different way. It's incredibly difficult. So they have imagination models. That generative is that one point that I made about you can make your data now. They've got all sorts of generative systems. So if I don't have the data, I just build a generative model and it can make the data. So I have enough data to then take and train something else. And some of the generative models are so good that you just use what they generate and you're done. You don't even have to pick that up and train another model in some cases. But they've got imagination, semantic models. That's really one of the other long poles in the tent, is semantic understanding. Most machine learning only operates at the surface level. They can tell a truck or a dog from a cat, but they don't know what a cat is. They don't have the sense of a cat or a dog or anything. They don't think very deeply. They just know this is a cat, that's a dog. That's it. So, and then the other things, processing power is going to make it easier to train, faster to train. Internet of Things, augmented reality. I think that's actually one of the big futures, is being able to have a pair of glasses that show you things, kind of like Iron Man inside his helmet kind of a feel. I mean, obviously not all that stuff, but imagine walking down a production line in a manufacturing plant and having glasses on that say that machine is 25% off spec. Just walking by it, and it'll tell you that that thing's out of whack, so that you can get the maintenance guys over there and fix it up. Or it'll tell you when you just look out across the floor and go, oh, wait a minute, that machine over there is out of spec. Those are the kinds of things that I see as near-term possibilities if you put AR together with machine learning systems. So these are all sorts, and we could talk forever. Empowered populations, there are many, many things. I'll put this back up when we're in the discussion section, which we're just about there. The only thing I want to say is let's not talk about any of these. Okay? Skynet isn't happening. You can talk about that all you want. Maybe in the distant future. AI is not going to render humanity obsolete anytime soon. Get over it. Blockchain is not going to eliminate banks, none of that kind of stuff. Get over that. And humans no longer need to work. Well, guess what? We're going to have to work for a variety of reasons for quite some time. So let's not focus on those. But we can talk about some of these things that are kind of in the cards, as it were, that may or may not come true, and are largely in our personal control through voting and a variety of things. So with that, I'm finished. Used up most of the time, but questions that didn't get asked?
Specifically, what issues do you see with implementing blockchains on voting or gathering voter data? Technical issues.
Technical issues would be privacy and access. One of the things, one of the dirty little secrets in the world today is not everybody's got laptops and high-end phones and all that kind of stuff. So your challenge would be reaching everyone, because voting is for everyone. So would be the biggest challenge I would see, is how would you make it so that somebody in rural, wherever, can vote.
It would paint a clearer picture. You remove the privacy portion of it, of how we vote as opposed to running back polls, right?
Oh yeah, no, I would think, and actually that probably is going to be a startup of some kind of, and actually there's a whole sea of startup ideas around that, where you just poll them live. Because right now polling is imperfect in a dozen different ways. It's an exit poll, it's got selection bias, it's got all these other problems embedded in it. If you could get to a large enough population and you could ping them regularly, where all they have to do is say yeah, no, you could tell which way they're going. And then if you have that with blockchain, and they knew it had blockchain, they'd be much less inclined to say goofy things, because they know that, look, I said I was going to vote for this, and then when you don't vote for it, it's like, well, wait a minute, why didn't you vote for that? It's not that you can hold them accountable for it, but the knowing that it's tracked is going to make people respond more honestly at the beginning. Just knowing that if somebody really wants to go take a look, they could.
Could you design a voting system to retain the privacy of a user, that only the system has information to that?
Yeah, that would be like a hospital system. And there's any number of ways you can make the privacy. Again, it's that separation of the data from the hashes.
Right.
And so as long as that data layer was protected and behind a highly secure environment, yeah, you could. And also, as long as you broke the data apart in the right way. Because one of the things people don't realize is if I have a couple of 3 data points, I actually can figure out that data belongs to you pretty quickly. It's surprising how little I need to know to take it right back to the individual.
You mentioned GDPR and the necessity within GDPR of forgetting. Is there a model in the blockchain of how to manage forgetting, which would have to include also copying? Are we?
That's currently under development. It's in the process.
There are emerging models on that, though?
There are people with theories about how to do that. That's those child chains I was talking about, and some of those matrix models, where if you split it, you can actually break it apart so that the information that you will eventually want to forget can be taken away, and the data you want to keep will live on that other blockchain. It's kind of the way to think of it.
So as an extension of that question, then, is there a way to model an ownership of data so that you can say that you have a legal responsibility to forget that data because I own it?
Well, that's what the blockchain, the upside to the blockchain is it will tell you the provenance of the data, so who it came from. So you can trace it back to wherever it emanated from, which would be you in this case. And so you could say, oh, I know this is your data. Even if I broke it apart, I'd still, well, I wouldn't be able to get back to you if I peeled your name off into a different thread. And so as long as that thread was alive, I could go back to you, and GDPR says after 2 years you have to get rid of the data. And so you build a smart system so that after 2 years your name goes away. Your
So
data may stay there, but your name goes away and no one knows it's you anymore.
So I could know with certainty that only me and the feds have my social security number.
Yeah, I don't know unless you shared it with somebody. And actually you don't need, social security number is a totally bogus
No,
thing.
I know it's bogus. It's just an example of a common piece of data that we would want to be able to have fee simple rights to.
Right.
That now we can't control, and I'm wondering if within the scope of blockchain, if you could model it such that that would be a possibility.
Yes, with biometric markers. So when Social Security was just a construct that was efficient at the time. It was the only way to do it at the time. You give a unique ID to somebody. That's what it is. Your unique ID, you're carrying it around. Actually, when you speak, your voice is unique. We have a whole bunch of easy, actually, now with machine learning, they're easy to track. It used to be retina things and things like that. We've gotten to the point now where there's technology on the shelf that can just our voice pattern alone can't be spoofed. It can sound like us to our ears, we can hear it, but from a statistical perspective, I guarantee you can't fake a voice.
So Google can't hear those frequencies and put them all back together identically.
No, they would not be able to model the lilt of your voice and all the parts. And then also you get into 2-factor things. So you have your voice and your face, okay? They might be able to eventually play with one, but the odds of them getting both of those and getting them to fit together is incredibly low. And then if you want to be totally safe, you can go to a heart rate monitor and a couple of other, you could do 10-factor to where no one could fake all of that in one fell swoop.
Second item from the bottom, as we get smarter and we come to things like this and we learn, what happens 30, 40, 50 years down the road when we've got a serious problem in the second to last item? Do we drive ourselves to a socialistic provider for everybody?
That's,
Do we drive ourselves into a
I would say,
reproduction?
I would say
Where do we go
the,
with
well, in my mind, there's people at the top that are making billions of dollars. We have hundreds and hundreds of billionaires in this country. You take a little bit of money out of their pocket and you can have a minimum living wage for everybody on the planet. There's no reason we have to have the problems we have. You could take 1 or 2 aircraft carriers off the list and solve our infrastructure in the entirety of the United States.
Is that a 30-year program, a 100-year program? Because you've got basic inherent infrastructure that will fight you tooth and nail.
That's all those incumbents I was
They all
talking
die
about.
off
Yeah.
unless they stop dying off.
Right.
The way we treat health,
Right,
we're living
right.
way beyond
Right.
what Social Security was originally predicated on.
Well, and that's one of those things where the social dynamics come into play. You've got a lot of people, if everybody just stood up and voted, you know, our democracy actually could work. The reality is hardly anybody votes. And so if everybody finds themselves being unemployed,
They'll start voting.
they'll start voting.
Yeah.
And they'll start getting serious about it.
Well,
and-
folks will figure out how to do that sooner.
It'd be better if we could do it in an orderly fashion, I agree, but that's not what I'm about, so. I'm not gonna solve that one, sadly.
Just a random thought, but if you go down to South America and see the Inca walls, has anybody seen those? The Incas built walls all over the place, and when you go down there and look at them like Machu Picchu and around there, why did they build all these walls? And no one really knows. No one even knows why they built Machu Picchu. They don't even know that anybody ever lived there. And so one theory is they had mastered health, because they didn't have smallpox or anything like that in that part of the world yet. They had mastered what killed them. Diseases weren't there. They grew enough food and they had enough clothing, and it was warm weather. They really didn't need to worry about winter all that much. So they got all their needs taken care of as a society, but they had all these extra people and they had to keep them busy. So they had to build these walls that were totally not needed and totally useless, and they didn't even have beasts of burden back then. They didn't have horses to move those rocks. So when you really study that culture, they brought those rocks from a long ways away with no horses or donkeys or anything like that.
Yep.
And so they kept the people busy, perhaps, building walls. Maybe that's what we're gonna have to do.
Well, society is
It's kind of a
pretty
strange
amazing,
thought.
and why past cultures did what they did is, will be a mystery for some time.
Yeah, I've seen some stuff that the blockchain could be a good tool for co-ops, both platform co-ops, but also brick and mortar co-ops.
Mhm.
Can you comment on that?
Yeah, I would think that's a good application, because that's a way for them to work together without having to have all the current paperwork that goes with that. So you could have, if they're a farming co-op, they could have tractors in a shed that are all on the blockchain, and that, when I needed a tractor, I go in there and I pay a few tokens and go do my field and drive it back into the shed, and somebody else can do it, and there'd be somebody else in the ecosystem that maintains all the tractors. And that'd be an excellent type of model for co-ops, collaboratives of various types.
Would help with the unemployment.
Yeah, well, actually, I think there's a ton of service jobs. We have all manner and kind of societal problems where, if we had minimum income and somebody didn't have to worry about working for a living, but wanted to help out. And so it's a cultural shift, helping the elderly who are housebound, just going out, walking down the block and making sure somebody has a lunch, or those kinds of things. We could employ millions of people with those kinds of jobs.
So we got time for one more question.
If no one else has a question.
You're the only hand up.
I'm the only one. I'm curious, you mentioned the thing in China, and I heard something about that. To what, I mean, could they actually identify individuals?
Oh yeah, they got their name. Actually, if they violate too many rules, they can't get loans. Their kids can't get into school. And they've already done this. This is not a future thing. In Shanghai, this already exists, and they're already doing social engineering in Shanghai right now.
And not only if you violate the rules, if someone close in your network violates the rules, your score goes down too.
Yeah, yes. So you're motivated to make sure nobody around you misbehaves. Because if they're part of you, you take a hit too. Yeah. Oh,
So Jay, the worst part is if you have a low score, you don't even get to see the good-looking people on the dating sites.
yeah. Swipe nowhere. All right. We're good. Thank you very much.